Welcome to this episode of At Home with APS. Hi, my name is Mrs. Gaudette, and I'm here with you to work with 3rd, 4th, and 5th grade math. So we're going to start our activity today with something called a quick image. What I'm going to do is I'm going to flash for just a second or two a design at you. And I want you to try to figure out how many there are, how many dots there are. All right, so let's go ahead and try this. So again, you're thinking about how many dots are there altogether. Think about what pattern you can use and how you can try to figure that out. All right, here we go. How many dots were there? Did you see them in a certain way? All right. Remember, I'm going to be asking a lot of questions, and it's to you to go ahead and try to solve with me and problem solve and think about it and call out the answers. If you're at home, go ahead and call them out. And if you're in a spot that you can't, then just quietly think about them. All right, I'm going to flash it again. Did you revise? Do you have the same number? Do you know how many dots there are? All right. I hear some of you saying, yes, I know how many there are. All right, so let's go ahead and let's have a conversation and think about the different ways that you saw this. So some of you may have saw right away that it looked like dice. All the dice have 4 on them. Did you notice that pattern right away? I sure did. Did you see how there could have been arranged to help you figure out how many dots there are? All right, so this is one way I saw it, and I bet some of you saw it this way too. I saw it where I had a group here, a group here, and then my 2 individual. So with that, I could have done where I had 2 groups of 1, 2, 3, 3 times 4. I had 2 of those. So if you have never seen this, or if you have, it's a good reminder, when you have 2 groups of something, we go ahead and put what we see and then put it in parentheses because the 2 means multiplication. Or another way to represent it is 3 times 4, that's one group. And I'm going to add 3 times 4, another group. Either way that you represented, it's fine. Then I saw the individual 4s. Plus 4, plus 4. So, how many dots did we have altogether? I have 4, 8. Does this starting to sound like yesterday where we were counting by 4s with the disappearing sequence? Yeah. 4, 8, 12, 16, 20, 24, 28. Oh, I almost messed up there. And 32. I know another way you could have seen it. I could have seen it this way, where I had one group here, I had a second group here, and then I had a 3rd group here. Did anybody see it that way? Where I actually had 3 groups. So 3 groups of 3 times 4. I already hear you yelling at me. Yeah, there's not a 4 there. You can't do that, Mrs. Gaudette. But there is a way to do that. So I have my 3 groups of 4. But then because I added in an extra one before, I got to take it out. So I subtract that. So 3 times 4 is 12. 12 times 3 is 36. 36 minus 4 is the 32. I know another way that some of you just said, Mrs. Gaudette, all I did was I just took it all, and I knew it was 4s, so I just counted the dice. 1, 2, 3, 4, 5, 6, 7, 8. So I just did 8 times 4 is 32. Did anybody do it that way? I'm one of those ones where I try to see if it's a pattern and it's repeated. I just count how many there are. All right, so we're going to do another one, very similar to what we just did. I'm going to flash it at you, and I'm going to ask you to figure out how many there are. You getting how this pattern is? We're going to do several like this. So let's go ahead. I'm going to flash it. How many dots are there? How did you see them? All right, let's see if we can confirm what you already thought or if you need to revise. Take a second and confirm, were you right, or revise your thinking. Okay, let's go ahead and reveal, and let's think about all the different ways that we could have come up with this one. So, I know what I did. I'm going to come up with this one. I can see right away. I have one group, two group of 4s, right? I know there's 1, 2 in each group. So I had 2 groups of 2 times 4. So what is 2 times 4? 8. 8 times 2? 16. All right. Now the last time I came up with 3 ways. Can you guys come up with another way before we just do the overarching one? Well, I could have done it like this, right? Could have done that. 2 groups of 2 times 4. Maybe some of you actually saw it this way, where you had the 3, because last time we kept doing 3 and you're just like, I'm stuck on 3. So you may have done 3 times 4. I only had 1 groups of those plus 4. So 3 times 4 is 12. 12 plus 4 is 16. And like me, some of you may have done it this way where this was an easy one. You're just like, wait a minute there. There's only 4 there. 4 times 4 is 16. If you're one of those ones who sees that pattern right away, what I want you to do is I want you to start picking out and trying to find other patterns. If you see this one right away, that's fine. I'm going to ask you to push yourself and see it a different way, okay? All right, because sometimes when we can come up with multiple ways to get the answer, we're actually better off. So I'm going to give you another one. Again, I'm asking you to tell me how many dots do I have, and then think about the ways that you can see it. All right, so I'm going to reveal it. All right, how many dots did you see? How did you see it? Again, if you can come up with one way right away, see if you can come up with another way. All right, I'll reveal again, and you can confirm or revise. All right, so if again, were you correct the first time? And if you were correct the first time, did you see a separate pattern? Let's reveal and let's look at all the ways you can do it. Not all the ways, just a few ways that you could do it. All right, I'm looking at this, and the first thing that I see is I notice that there's some here, and then an oddball in the middle. So that's the pattern I recognize right away. I have one group here, and then an oddball. So I know I have 1, 2, 3, 3 4s, and I had 2 of those, and then I had my oddball. So let's see, how how many dots were there? I had 3 times 4 is 12. Thank you. 12 times 2 is 24. Add another 4 is 28. Thank you very much for helping me out with that math there. All right, did anybody see it another way? Yeah, I heard some of you say, what, the 3s, what about if I went across and did 2s? And I went across and did the 2s. You notice I'm gonna go around that oddball. If you added that in there, great. I did not when I went through. And I said there was 1, 2, 3 groups of 2 4s. And then I had the oddball 4. So 2 times 4 is 8. 8 times 3 is 24. Thank you. 24 plus 4 is 28. And I can hear some of you yelling at me, you can't do that. You can't do that. What if I had the 2 here, and you were one of the ones that had the 3 here, and then the 2 again? Could I have done that? Yeah, sure. I could have had the 2 groups of 2. So the 2 times 4 plus the 1 group of 3 4s. Okay, so 3 times 4. So let's do that math. What's 2 times 4? 8. 8 times 2 is 16. Hold that 16 in your head. Then I have the 3 times 4 is 12. Now I can add those 2 numbers. The 12, I have to add it to the 16. What does that get you? The 28. Then, of course, as a lot of us can see, now we have 1, 2, 3, 4, 5, 6, 7. I have 7 groups of 4, which is 28. So this one, you could have seen it multiple ways, which is perfect. Because if you're really thinking about math, there's never just one way to solve a problem. There's multiple ways to approach it. And I love these quick images because that gives us that information to help us out. So I have another one for you. Don't want to give it away too soon to you. All right, so we will follow that same pattern. I'm going to reveal how many are there. So how many dots did you see? And then how did you see them? I have an idea. Do you have an idea? Thank you. I hope you do. Let's see again. Confirm or revise. And if you came up with an idea and you confirmed it right away and you can come up with another pattern, do that. Were you right? Did you revise? Because remember, it's okay to be wrong. It is okay to make mistakes. We learn more from our mistakes than we learn if we got it all correct right away. All right, so let's look at some patterns here. All right, I can see a very easy, simple pattern right away. I see 3 rows of 3 4s. So I have my 3 rows of 3 times 4. I don't have any oddballs. It's a nice, beautiful little cube pattern for me. So we have, what's 3 times 4? 12. 12 times 3? 36. I'm looking at this and I can see it where if I could have gone down 1, 2, 3, I would have the same, pretty much the same equation. Was there another way that you saw it? Yeah, some of you probably did see it that way. 1, 2, 3, 4, 5, 6, 7, 8, 9. I know this looks like a 9 pattern. So 9 times 4 equals 36. Could you have seen it a different way? Yeah, I don't see a different way, me personally, but you guys always come up with way better ideas than I do. All right, let's do one more. This one you're gonna laugh at. You're gonna think is so easy compared to what we have been doing. All right, let me flash it at you. How many dots did you see? How did you see them? All right, revise or confirm, and if you're confirming you saw it right away, find a different way you could have came up with that. Were you right? Did you see it a different way? All right, let's reveal and let's look at it. Yeah, I know you guys are like, that was easy compared to the last one. If you saw this way, one group of 2 4s, 2 groups of 2 4s, 3 groups of 2 4s, that's the way I saw it at first. So we have 2 groups of 2 times 4. Oops, I'm sorry, 3 groups. Thank you for correcting me. See, isn't it fun when you can find the mistakes your teachers are making and tell them that it's showing them you're paying attention? I know I love it when my kiddos do that for me. What's 2 times 4? 8. 8 times 3? 24. All right, what's another way we could have seen that? I see it that way too. Do the rows of 3 4s. So now I have 2 rows of 3 4s. What's 3 times 4? 12. 12 times 2? 24. And for those of you that just saw it all together, just saw the big old one, 1, 2, 3, 4, 5, 6. You saw the dice pattern. You knew without even having to count like it was 6. I had 6 groups of 4, which is 28. Thank you so much for helping me out today with some quick images and looking at dice patterns. Mrs. Sears is now coming on to work with you with some tasks.
And Ms. Gaudette, just so you know, 6 times 4 is going to be 24. Because you got 24, 24,
Thank you.
and 24. And that would be the same for all of them. But that's good. I like catching your mistakes.
Yes, thank you.
All right. Hello, mathematicians, and I am Mrs. Sears. I wanted to kind of give you a little bit of background of what we're going to be doing today. We're going to be doing a problem-solving task, and today it's going to involve number riddles. I wanted to let you know if you have a notebook at home or a spiral or even just an extra sheet of paper, you're going to want to write down these problem-solving tasks every day. And that can kind of give you a little bit of a review of concepts that you might want to be working on, okay? So it's just an opportunity for you to be able to work the problem out along with me. And the way that I'll be working out the problems are kind of the way that I'm thinking about them, a lot like how Miss Gaudette was doing it, and she was thinking about those shapes, those different number patterns. She was revealing to you her strategies and her way of thinking. You may have a totally different way of doing the strategy, and it helps if you already have the problem written down that you can kind of work out different ways that you would have solved it. All right, so let's go ahead and begin. Our first number riddle is about who am I? And I have it written all over here on our chart paper, as well as I'm going to be actually working through the problem for you on the board so that you can kind of be looking at my thinking. But if you needed to look back to what the actual problem was, you can always do that by looking back up here at one of the charts. All right, let me grab a pen real quick. All right, so this one says, who am I? I am a 3-digit number, okay? I am even. The sum of my digits altogether is 15, and the order of my digits goes smallest to largest, left to right. I am a multiple of 7. What number am I? Can you think about that right now, what you might do first? I know as I'm looking at the clues, the first thing that draws my attention is the very last clue. I'm a multiple of 7. How could I figure out what that number's going to be if I just thought about sevens and what numbers I could play with as I'm counting by sevens or skip counting by sevens? Well, I already know that 7 times 10 is going to be 70. That's not going to work for my first clue, which was I'm a 3-digit number. I'm wondering if maybe I did 7 times 20. That's 140. That's 70 plus 70. Would that work to be maybe my number? I don't think so, because the number that it's at, the third clue tells me that all of the numbers together are going to add up to 15. So I think what I'm going to start to do is actually, I'm going to start to think about that problem. Let me get a blank sheet of paper here. Hopefully it'll work. There, perfect. And I do need, I believe, to be able to write on this. So I'm going to make sure I have some color for you. All right, I'm going to be thinking about those sevens. Now, I already know, like I said, it's got to be a 3-digit number. So I'm going to start thinking about it from my 70, because that might be an easy number to start with, okay? If I'm skip counting by sevens, what's the next 7 that I would go to? 77, right? What about next? 84. Kind of feels like what we were doing over here. And 91, 98, 7 more, 105. Okay, I'm into those 3-digit numbers. All right, would that work for my third clue? Remember, they have to add up all together to 15. Well, I have a 1, a 0, and a 5. If I add 1 and 5, that's only 6. Okay, got to keep going. 112, 119, and Miss Gaudette, please stop me if I'm counting these wrong. 126, 133, 140, there was that 20, right? 147, 154. Ooh, that took a little second to think about. Now let's see, I'm going to start counting these numbers just to make sure I didn't miss something. So 147, so 1 and 4 is 5, and 7 is the 12. Plus, I also know it's got to be an even number. So 147 wouldn't have worked. Let's try 154. 1, 5 is 6, and 4 more is 10. That one's not going to work. If I do 161, that's an odd number. How about 168? That one I think is going to work. Let's see. 1 plus 6 is going to be 7, plus 8 is 15. My number is 168. Cool. Did you figure that out? Took me a little bit to get there, but we did eventually figure that out. All right, let me go ahead and move that off. We'll go to our other one. And we want to just hit the screen? Okay. Twice. There we go. Got another one. Technology, don't you love it? All right, who am I? This time we have a 4-digit number, okay? So we're going to be up into the thousands, we know. I am an odd number, okay? So when I say it's an odd number, what's usually the digit that's going to tell me if it's even or odd? It's our ones digit, right? So I know something about that ones digit already. 0 is a placeholder in 2 of my values. All right, so if I have a 0 in there for 2 of my value, that means when I'm reading that number, I'm not going to say those zeros, right? I'm going to need to think about how I'm going to read that number. the sum of all my digits, okay? I know I got 4 digits, but the sum of all of those digits, including those zeros, is only going to be 7. And the product of 2 of my digits is 10. My thousands digit is even. My tens and hundreds digits are less than 2. That might give me a good clue of where maybe those zeros are going to lie. And the order of my digits is going to be least to greatest, not including those zeros. Then I want to be able to read this number at the end. So let's see if we can do that. Are you ready for the challenge? Maybe take a second, make sure you have all the clues. And again, if the clues are not on the screen as we're working through the problem, we're going to have it right here behind me on the chart. All right. Yeah, that's true. Thank you for reminding me. I will get that. It's stuck up here. Perfect. So let's make sure everything is on there for that one as well. All right, I'm going to put that right there. Okay, you ready? Let's go. And go to some twice. Perfect. Okay, now I want to be able to write on this again. Let's do black this time. Okay, so let's think about those clues. 4-digit number, right? So I'm going to go ahead and just make my spaces right now for that 4-digit number. And what do I need to have going in 3 spaces? A comma, right? Because that comma is going to tell me that says 1,000. That's how I know where it's going to lie, okay? So we know it's got to be an odd number. So this over here is going to have some kind of an odd component. So let's think about our odd numbers. We have 1, 3, 5, or 7, right? Okay. Oh, and 9. All right. We know that the hundreds and the tens digits are less than 2. And we also have I believe it's a placeholder of 2 zeros in there. I'm just gonna take a stab in the dark and try it because I know I've got 2 zeros in the placeholders and I know that these numbers are also less than 2. I'm gonna go ahead and start with those. Okay, see if we can find some other clues. Let's look down at the 4th clue. It says the sum of my digits is 7, okay? And the product of 2 of my digits is 10. How many ways could I get to 7 if I'm adding? And thinking about it, that I have to have an odd number in there. So if I had a 1 with that, and I started with, let's say, a 6, I would have had to have 1 plus 6, okay? That would give me 7, right? So let's see. So if that was 6 and 7, that doesn't really fit in my last clue. The order of the digits is going to be least to greatest. So if I did put that here, let's just see if I did put that here, the least to greatest, oh, that would work there. But it doesn't work for my clue about the product. The product of 1 times 6 is going to be 6, right? Let me see if I can just get rid of that one. All right, let's do the next one. Okay, so we have a 3. We could do a 3. Oop, I'm on erase. Let's do 3 plus 4. Okay, that would work, right? Because we could have the 3 here and the 4 could be here. But again, it doesn't fit my product riddle, right? We have to have a product of 10 with those 2 digits. So that one's not going to work. I'm just going to cross that one out, do that. We're at a 5. All right. I think we maybe have a winner here. Let's see. So we have what plus 5? Okay, 2 plus 5 is going to give us 7. That would be the sum of those 2 digits. What would be the product of 2 times 5? 10. Yeah, that would definitely work. Okay, so now we've got to think about where am I going to put it? Well, I already know I have to put a 5 here because I know that 1's digit is going to be odd because otherwise the number wouldn't be odd. And I'm going to have to put this number here. What is our number? It is 2005. Okay? Did you hear me say any hundreds? Did you hear me say any tens? I read those because we don't say them because they aren't part of that problem, or they aren't part of the way that we would read it. We would read that as 2005. All right, do you think you can do one more? I think I'm ready. Let's get over there. Click twice, right? Perfect. Take this one down. I'm getting there. You're reminding me. All right, I'm gonna put this one over here. They're all gonna fall down eventually, but we'll try to keep them going. Okay, so given the following clues and their place value, this time we have a puzzle. Can you figure out this puzzle? This is a place value puzzle. So you're gonna have to read the clues and you're gonna have to know where to put them in which place, right? So it's kind of a little bit of a dual purpose. I'll ask you if you can, when we get to the next screen, if you can draw in those places like on a place value chart. That might help you get this a little bit quicker. All right, so let's think about this. We have to put the quotient, that's an odd word, I haven't heard that word in a long time, a quotient of 21 divided by 7 in the hundreds place. So I'm gonna have to do some kind of division. The quotient is gonna be the answer that I'm gonna get when I get 21 divided by 7, right? And I'm gonna put that in the hundreds place. Put the sixth smallest prime number in the 10,000ths place. Find the product of 4 times 2 and put it in the tens place. Subtract the digit in the 10,000ths place from the tens place and put it in the ones place. Divide 120 by 30 and put that digit in the thousands place. We're gonna have to read that number recreated, and then at the end, if we have time, I might be able to leave that one for you guys to see if you could do it in expanded form. Are you ready to try it? Again, clues are gonna be over here. And if you had some time, maybe you drew that first place value chart like I have on there to help you. All right. I got a bigger version of it here. And we want to make sure we have something. Let's do red. All right. So what do you notice up there? Well, I have my 100,000s. I have my 10,000s. Have my thousands. That's marked by my comma. That's why I know how to say thousand at that point. Hundreds, tens, and ones. Do I have any decimals here? No, I don't. Okay. Let's see if we can figure this out. And I know we have some more time that we can maybe work on this possibly tomorrow. I'm going to go ahead and have Miss Gaudette see if you can get the clues and try this on your own at home. And I would really like for you guys to be able to send us more of these number riddles so maybe that we can do them here on the show as well. And you can do that by either tweeting us at @homewithaps or sending us an email at distancelearning@gmail.com. So let's try that out. Have fun, guys.
All right, so we're gonna move into our reading portion of today. So I have a great book that has little problems on it on every page. These are fun to think about. So we are gonna be reading The Grapes of Math by Greg Tang, illustrated by Harry Briggs, and published by Scholastic. This is a mind-stretching math riddle book. I love this. Beautiful pictures in it. Fish school. Of all the creatures in the sea, a fish is smart as smart can be. While others swim and play it cool, a fish is happy in a school. How many fish are in this class? Answer quick and you will pass. Here's a hint, a little clue. When counting fish, just look askew. You can actually turn this book, and can you see the different ways? I have rows of 4. How many rows do I have? I have 4 rows of 4, so that makes how many fish? 16. The grapes of math. I stroll along a vineyard path, And there I see the grapes of math. Overhead, the sun is blazing. Soon each grape will be a raisin. How many grapes are on the vine? Counting each takes too much time. Never fear, I have a hunch. There is a match for every bunch. Did you see how you can match it? So I have how many? I have 1, 2, 3, 4, 5, 6, 7 in the purple grapes, and then 3 in the green grapes. So if I matched these two, matched these, and then these, so that would make 10, 20, 30, 40, 50. I like this math. Snail Parade. One day, while walking through a glade, I came across a snail parade. Rows and rows of snails I spied. How do I count them all? I cried. Don't just group the ones you see. Consider where a snail should be. So how many snails are there? Did you figure it out? Well, I know that if I did the first row has 1, 2, 3, 4, 5. The second row, if I filled it in, would also have 5. 5, 10, 15, 20, 25. There's 25 snails. Nah, you're right. You're all Mrs. Gaudette, you have those extra ones. So if I had 25 and 1, 2, 3, so 25 minus 3 is 22. I'm making sure I'm doing my math right in my head, just like you are. So we have 22 snails. Ant attack. It's a picnic. The ants all scream. How many ants are in this scene? Try to count them one by one. Before you finish, they'll be done. Find a square before you count. Soon you'll see the right amount. Do you see the square right here of a 4 by 4 ants? How many's in 4 by 4? 16. And then there's 1, 2, 3. 16 plus 3 is 19. So let's go on to the next one. 1 hump or 2. Rugged camels on the go despite a lack of H2O. They trek all day under the sun. Some have 2 humps, others 1. Can you add all the humps you see? Don't just count them 1, 2, 3. To help you find the right amount, group by 5s before you count. Did you see the grouping of 5s? I didn't at first either. I was trying to count this way. It didn't work. But if I counted down, I see 2, 4, 5, and then I realized, wait a minute, there's 2 of the 2s and 1 of the 1s, so it's 5, 10, 15, 20, 25 humps. Do you see that pattern? Yeah. Sweet cherries. Apples are crabby. Berries are blue. Cherries are sweet, and so are you. Did you see that little one? I love that. How many cherries do you see? Please don't count them separately. Pair the cherries bunches by bunch. Add them quick before their lunch. So you notice I have 1, 2, 3, 4, 5, and I have 5 here, but that would work. So I have the 10, but then down here I have 1, 2, 3, 4, 5, 6, 7, 8, 9. That won't work. But down here I have 4, 1, 2, 3, 4. Could I have done that? The 6 and the 4, I can make that another 10. And then I know I have 1, 2, 3, 4, 5, 6, 7, and a 3 makes another 10. So 10, 20, 30. What a great way to think about it, right? Doggone it, prairie dogs. Prairie dogs don't hunt or bark. They won't protect you in the dark. Instead, they burrow, digging holes, making tunnels just like moles. Can you count the empty mounds? It's best to just subtract the hounds. Did you figure out the pattern in this one? So in this, I know that there's 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 mounds here. Did it work with the 9 mounds here? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, 9, 9. So I have 9 times 3 is 27. And then I have 1, 2, 3, 4 prairie dogs. So I got to get rid of those 4, subtract those 4. That gets us to 23. Large pizza to go. Mamma mia, pizza pie. How many mushrooms do you spy? Please don't count them, it's too slow. This hot pie was made to go. Let me give you some advice. Let's just do half and count it twice. So they're suggesting to us to take half of it and count it up. Did you find another way to do that? I like the patterns. I went 1, 2, 3, and then I noticed the 2 next to it had 3, and I thought, I could just do 3 times 8 is 24. If you did half, you would have counted 12, and doubled it is 24. Multiple ways to solve it. Know your dice. Come on, lucky shiny dice. Roll a pair and count it twice. Boxcars, snake eyes, double threes. Can you add up all of these? Before you start, please look around. Adding's fast when tens are found. Ooh, I like that little clue. Did you know which ones the boxcars are? I never heard that before reading this book, and I had to look at them to figure out the boxcars. Yeah, it was the double sixes are the boxcars. Do you know which ones are the snake eyes? Yep, the 2 ones, and then the double threes. So did you figure out how many there are here? So if you try to find 10, if I went down right away, I know that's more than 10. Did you try going across? 6 and 3 is 9, plus 1 is 10. 10, 20, 30, 40. See, now you see our dot patterns coming back in, but a little differently. Strawberry seeds. Strawberries grow along the ground. A better treat cannot be found. Their seeds reside in tiny rows. From each of them, a plant will grow. Just how many seeds are there? Count them only if you dare. Here is a little trick of mine. Pair the rows that sum to 9. Summing it to 9. So let's start. 1, 2, 3, 4, 5. That doesn't work. I need to get a lot more than 3. If I paired it like up here, 1, 2, 3, 4, 5, 6, 7, 8. That didn't work, so it has to be this one. 1, 2, 3, 4, 5, 6, 7, and 2 makes 9. Did this work? Knowing me, I always just don't assume. I double check. Let me double check. 1, 2, 3, 4, 5, 6. And then I pair it with a 3. 1, 2, 3. 6 and 3 make 9. So I have 1 grouping of 9, 2 grouping of 9, 3 grouping of 9. So 3, 9, 18, 27. All right, there's 27 seeds. Windows. Oh, I love that little play on that. I lie in bed and try to sleep, counting windows instead of sheep. How many panes are filled with light? Here's a way that's really bright. So how many panes were filled with light? Did you figure out the pattern? Don't just count the lights you see. Subtract the rows where there's a Z. So look at that. Well, again, since it's nicely laid out for us, I can see that's 1, 2, 3, 4, 5. 5, 10, 15, 20, 25, 30, 35. 35 total windows. But I have 1, 2, 3, 4, 5, 6, 7. 7 minus 35 minus 7 makes 28 windows. If you have a chance, there's a few more in here, but it would be great if you had a chance to just find some books to be able to read some math, because there's always fun when you're reading.
We're going to get ready to play a game. Yes, I think so. All right. We're going to get ready to play a game, and we're going to be using, yes, our document cam. And the name of the game is called 30 More or Less Multiplication. All right, so let me explain the rules.
Okay, I'm trying to figure it out based upon the name.
Okay, so I have a deck of cards here, and you're going to have to do something different to your deck of cards. You want to take out the jokers, and you also want to take out the kings. Okay, your aces are going to be worth 1, your jacks are going to be worth 11, and your queens are going to be worth 12. Okay, so we're doing multiplication anywhere from our 1s all the way up to our 12s. Okay, so some of these might be a little multi-digit. You may want some scratch paper out to help you. Maybe you want some counters or something that you can try and figure this out, put it into an array. Could be any way that you want to do it. You're going to want to have a partner. All right, and what I have done is I have split the deck in half. You can also use multiple decks, okay? You don't have to just use one deck, but I had one deck and I figured we'll just split it in half. But you have to figure out first, okay, which side are we going for, okay? Are we going for 30 more? The two numbers that we got to pull the cards. I forgot to tell you that. We're going to have to pull 2 cards, okay? I'm just going to show them the first one. So on the first 2 cards, I pulled a 6 and an 8, okay? That one is 48, right? Okay? So if I was the side that had said that I was wanting the 30 more, I would have won that round, okay? Because I had 30 more. I had more than 30.
You don't know that. Because what about my cards?
Yes.
Okay, darn it. All right, maybe.
Well, we both have 30 more. I think it's just one set that I'm pulling. Maybe that's why I'm thinking it differently. Yeah. So you're either on the side of 30 more or you're either on the side of 30 less of what we pull. So you're going to get the cards. If I had chosen 30 more, I would have been able to take away those cards.
So I would have been stuck with 30 less.
Yes.
So would you have taken my cards also?
I would have taken your cards also.
Okay.
All right. So are we kind of ready to play?
We're going to have to play around for you to explain it, because that one was a little funky.
That one was a little bit different, and I apologize on that. And let me actually go ahead and put this kind of more down to the bottom so that we can actually have a shuffle. So I think you pull a card and maybe I pull a card. That's why I had the 2 decks there. All right. Okay, so let's do Rochambeau really quick. Rock, paper, scissors, okay? And this is where you're gonna decide whether you're 30 more,
okay,
30 less.
All right, you are just like throwing stuff at me now.
I am, I'm throwing things at it. It's been a while and I was just reviewing the rules of the game and it went right out my head. So,
all right.
You know, we have times. Ready? Okay, 1, 2, 3. Okay, I had paper, scissors, cut paper. Which do you want, 30 more or 30 less?
30 less.
30 less. Are you ready?
Yes.
I have shuffled them. We have a 3 and we have an ace. Okay, you remember, ace is a 1. 3 times 1, that's a 3. Does she win?
Yes.
She did 30 less. All right. Let's do a couple of more rounds. I think we have some more times.
I stick with the 30 less through this whole round?
You want to go ahead? You can do that.
Or does it change every time?
You could change it. Do you want to switch it up and try it again? Do you want to do another Rochambeau? No, you like your 30 less.
Yes, I do.
Chances are, I'm not gonna spoil the strategy, but we'll see. Okay, 2 times 6. is
12.
12. Okay, 30 more or 30 less. She's got it. All right, so far she's beaten me. All right, queen. Remember, a queen is a 12, okay? We have 12 times 7. Remember my little trick that I did earlier with the 7s? And I was skip counting by 7s? Well, the first thing that I did is I broke it up into that 10 times 7. That would be 70. So if I know I need 2 more 7s on top of that, 7 times 2 would be 14. I would be looking at 84. So 12 times 7, 84, more than 30. Da-da-da. Mine. I'm catching her. It just takes a couple of rounds and I'll catch her, right? Okay, 4 and 8.
It's yours.
It's mine, yeah. Well, we remember that was one of the sequences that you showed me. Yeah, 8 times 4 is 32, so more than 30. See,
Maybe I'm
back
going to
in the
lose
game.
this.
I'm
Oh, wait,
back in
I
the
want to
game.
do this again.
It's just, you never know how the decks are going to shuffle, so it's worth a try. Okay, 5 and 3.
All right, 15. It's
15,
mine.
5, 10, 15. Skip count it. All right. This should go a little bit faster. Jack, that's an 11.
Oh.
And a 10. Ooh, okay. Well, let's think about that. That jack is an 11. So an 11 is made out of a 10 and a 1, right? We can do the 10 times 10, 100, right? And then we have one additional 10. So 110, more than 30.
She got it very excited over that one.
I did. I like it. I like it when I see those face cards. Jack, it's an 11 times the 6. Okay.
66.
66. 11 times 6. Okay. Perfect.
I don't like this anymore.
You don't, do you want it? We can switch it up.
No, we'll do them around, and if I'm not winning, then
Okay.
all right, I'll keep it. That's a 1 and an 8.
Only if she wins does she keep it. Okay, 1 times 8 is 8. All right. I think we still have a few more minutes, so we probably can do a couple more rounds. So we have this is interesting. We have a queen and a jack. Remember,
Which
your
is
queen is 12.
12 and 11.
And 11. Okay, so I got to think about this a little bit because this makes me have to think about how I'm going to solve it. So I know they each have a 10 in them, so I know I'm going to have at least 100. What do I have left over that I still have to do? I still have to do that. I may have to write this on the board. Or maybe I'll put it here. I have to think about that. And I did not bring my marker with me. All right. So we had a 12 times
You
an
need
11,
another,
right?
You need another marker.
Oh, I need a different marker, and that's not a very big marker. And I think I'm going to be running out of time here. Okay. 12 times 11. Okay. Remember, we can say this could be a 10 plus a 2, and this could be a 10 plus a 1. So I know I've got to do the 10 times 10. I'm going to kind of think about this as like partial products. That's going to be 100.
Yeah.
I still have to do that 2 times that other 10, right? That's 20. So, okay, I'm done with that first part of the 10. I still have a 10 times the 1. Okay, and it is just a 1 because it's this one over here. That's 10. And, I forgot this one. I have a 2 times a 1. All right, let's add those sums up, and I think that'll be it. 132. I didn't really line them up really good, but that would be that answer to that. And I know I'm going to win it, so I'm just going to take it down. I'm curious how many I had and you had. I think we had a pretty even amount there.
She's just not going to let it go. She's actually now trying to see if she beat me or not.
Anyway, we're going to go ahead and wrap this up because you can also find these resources on the At Home with APS website. If you wanted to go back and do that place value puzzle that we didn't get to, or you also wanted to see more of those exploding sequences, and I also put some extra number riddles on there too for you as well. We have really enjoyed having this time with you today. We've had some good book time.
Yes.
We've had some nice little number riddles. You've got a new game to play. Yep. And the disappearing sequences, I'm always enthralled with those things as well. But we want to thank you for joining us at Home with APS. We'll see you later.
Have a great afternoon.
Bye.
Bye.